value and sketch the areas described. So you've got a couple ways you could do this. I'll show you how to do this in the calculator. I'll also show you how to use the z-table. So find z such that 7% of the standard normal curve lies to the left of z. So let's talk about this. Let me draw this out, what we've got going here. Yeah, standard normal curve. And so we got to find z such that 7% lies to the left of it. Now, the middle z-score is 0, okay? So if I define z such that 7% lies to the left of the z. So if 7% lies to the left, where would z need to be at? Below 0 or above 0? If 7% lies to the left. You know, this is the 50th percentile, right? So 7% lying to the left, 7% lying to the left means z would be down here somewhere. So I need to find what z is. So there's a variety of ways you could do this, okay? One way is you could go to the z-table and go work backwards. See where 7% is 0.07. You can find where 0.07 is as the one of these probabilities. Where is 0.07 or the closest to 0.07? Okay, so that would be, oh goodness, 0.07 right around there. Negative 1.48. Negative 1.48. That's one way to do it. That's using the z-table. So the z-table, it'd be approximately negative 1.48. Now, how do we do this using the calculator? Okay, what you can do is you can, if you need to find a z, you can use something called inverse norm. Use something called inverse norm. So it's second vars, option 3. So that's second vars 3. Second vars 3. All right, now area. So 7% is to the left of it. So that represents the area. So my area would be 0.07. So I got to express 7% as a number. Now for the standard normal curve, the z-curve, the mean is 0 and the standard deviation is 1. So inverse norm, area is 0.07, the mean is 0 and the standard deviation 1. If I'm ever trying to find a z, the mean 0, standard deviation is 1, because that's the mean standard deviation of the standard normal. Now, what I'm going to ask myself is that 0.07, is that representing the left area or the right area or the center area? What do you think? The left area. So I'm going to keep left selected. Old calculators do not have this option. Old calculators defaulted to the left area. So then I go press enter. You could also do this in SALT. I'll show you how to do this in SALT too. And you get negative 1.475, so negative 1.48, which it's pretty similar to the z-table. I'm not sure how many decimal places. For z's, it's usually 2. Sometimes it's 3. So I'll say around negative 1.48. Okay, so you see you kind of get the same thing using the z-table. All right. On B, I want to know the z such that 9% lies to the right of z. 9% lies to the right of z. Now, you could do this without drawing a curve. I'm drawing a curve for teaching purposes, so 0's in the middle. If 9% to the right, is z above or below 0? Where would it need to be for 9% to be right? Would it need to be down here or need to be up, down to the left or up to the right? Up to the right. So z needs to be up here because 9% lying to the right means there's not as much lying to the right. So this is 9% here. So to find this, I can use inverse norm. My area, what's my area this time? 0.09. This is harder to do in the z-table. Mean of 0, standard deviation of 1. And then which tail am I doing this time? Is it the left tail, center tail, or right tail? Right tail, correct. So right tail. Okay. And so 1.34. Okay. You could also use the z-table. Now the problem here is that 9%, if 9% lies to the right, this tells you what's to the left. You have to do 1 minus 0.09 if you use the z-table, which I think the z-table is harder. Then you have to find 0.91 on here, which 0.91 is 1.34. So there you go. As I said, I'm not a big fan of the z-table, but for everybody else, they can do what they want. Find the z such that 94% of the standard lies to the left of z. So let's talk about this. You don't have to draw it out if you don't want to. 94% lies to the left. Where would Z need to be? Above the mean or below the mean if 94% of it's to the left? 94% is a good chunk of it, right? So if 94% is to the left, where's Z going to need to be at? Below or above? Above, right? Z needs to be up here. For 94% to be to the left, Z needs to be up here. Okay. Okay, so now what do I do next? Inverse norm. Now, hopefully not too bad. I'm throwing a lot at you today, though. So we're going to take a couple days to unpack this. What's to the left of that? Oh, yeah, 0.9. I'm sorry, what's the area? 0.94, mean 0, standard deviation of 1. Is that the left area, center, or right? What am I concerned about? 94%. This corresponds to 94%. It's left, right? So we're going to put left. So 0.94, 0, 1, left. Salt will do this even better. Okay. You could do this using the table. Find 0.94 on here. 1.55, 1.56, somewhere in there. So find Z such that 93% lies between negative Z and Z. So this is interesting. So between negative Z and Z. So I've got negative Z down here, positive Z down there, or up here. 93% lies between. So where should I be shading this time? Between 0.93 there, 93%. So I can go to inverse norm, 0.93, and then 0, 1. Now, what am I concerned about this time? The left, the center, or the right? Center, because this is a center. It's between upper and a lower, and it's symmetric, so that's why it's going to give you. Now, it's going to give you two values. It's going to give you the value of negative Z and positive Z. I think on your homework you need to put like the positive version, but it's the negative Z would be negative 1.81, and the positive Z would be 1.81.